Good evening, Titans. And tonight we're going to be discussing factor by grouping. But before we get into that, we're going to review just a little bit what you've done in class during your block schedule day about GCF, or greatest common factor, factoring. First of all, remember that factor can be a verb, and that's one of the things we're doing is we're going to be factoring polynomials. And to factor means the process of writing a sum as a product. So we're going to change this polynomial, which is the sum of 2, 3, 4 terms, and we're going to rewrite it as the product of two factors or possibly more. Now remember, a factor is a number or a polynomial that is multiplied by another number or polynomial to form a product. And that's the factor as a noun. And then also remember that greatest common factor is the greatest factor that is common to all terms of a polynomial. So we take a look at a couple of factoring by GCF here as just a review. In this first binomial, we look at the two terms, and we notice that each term has a common factor of 5 and also has a variable b. So my GCF is 5b. So I write that on the outside, and now I have to decide what has to go inside the parentheses. And we determine that by now dividing each of these terms by that GCF. And so if I take 10bc divided by 5b, I'd be left with 2c. And if I take 5b divided by 5b, I'd be left with plus 1. And it's important that we put the plus 1 there because, again, however many terms are in our original problem or how many terms have to be inside the parentheses there. So my final answer is 5b times the quantity 2c plus 1. In this second example here, we take a look at it. 3 and 4, they don't have any numbers in common except for 1, and we're not going to factor out 1. And the variables aren't the same. So in this case, there is no GCF, so we call this a prime polynomial. A prime polynomial occurs when there are no common factors, and there's no other way to rewrite this as a product. Now in this third example, I just wanted to throw out in this first term, 1, there's a negative. So we usually don't like to have a negative in the front of the first term. So we're going to factor out a negative along with, it looks like 4 is common in every term. X is common in every term. Remember, we take the lowest exponent of x, so that's just once. And y occurs in every term. And again, the greatest number of times it's common is the lowest exponent, which is just y. And now I have to decide what goes on the inside. Well, remember, I'm dividing by my GCF. So a negative divided by negative would be a positive, and I'd be left with just an x there. Then a positive 12 divided by negative 4 would be a negative 3. And again, I'd just be left with a y in this case. On the last term, a negative 20 divided by a negative 4 would be a positive 5, and the variables would divide out. Because again, we're dividing by the negative 4xy, so the y's divide out, the x's divide out, and negative 20 divided by negative 4 is a positive 5. And so now we have our final answer. So notice, because I factored out the negative, every sign changed inside the parentheses. Well, now, we're going to factor by using a common binomial factor. And that just means it's a binomial that's common to all the terms of the polynomial. If you notice here, this represents a product. This represents a product. And so those are separated by that plus sign, which means that we have two terms. And what's common in these two terms? Well, it appears that the binomial factor of t plus 1 is common in those two terms. And if I take that t plus 1 and I take it out, or I undistribute it, I'm going to be left with r plus s. And now I have a product of two binomials. Notice there's no addition sign or subtraction sign between the two binomials. And now it's completely factored. If we look at the second example, I think it's pretty easy to see that, well, first of all, it's a plus, so we have two separate terms. And what's common in both those terms? Well, the binomial factor of x minus 3. And if I undistribute that, or I take that out, I'm left with a plus 6. So my final answer is x minus 3 times a plus 6. And in the final example, hopefully you're getting the hang of this, the common factor would be the binomial b plus 4 times, again, once we undistribute, we take that as a factor on the outside, I'm left with a plus c on the inside. So that's factoring when the binomial factor is already separated. Well, now we're going to look at factor a polynomial by grouping. If you notice here, we have 1, 2, 3, 4 terms. And there is no greatest common factor of all 4 terms. 3 isn't common in all 4 terms, 7's not common in all 4 terms, and x doesn't occur in all 4 terms, so there's no greatest common factor. But it doesn't mean that there's not a way to factor this. And so we call this grouping. And if we look, we notice that in the first 2 terms, they have something in common, and in the last 2 terms, there's something common. Now, obviously, in this particular problem, it's written in a way where the first 2 terms and the last 2 terms have things in common. Well, now we're going to end up factoring multiple times. We're first going to use GCF factoring in this binomial, and the 3x is common, and so we put the 3x on the outside, and if we divide 3x out of each one of those, we'd be left with x plus 1 on the inside. And in the second grouping here, 7's common in both of those. So we're going to factor the 7 out, and we'd be left with x plus 1. Well, now we're back to what we did on the previous slide, and we notice that we still have a sum of 2 terms, but now those 2 terms have that common binomial factor of x plus 1, so we're going to undistribute that, and we'd be left with times 3x plus 7. Now, typically, I like to write that on this side, but in this presentation, it's written on the left side. So we take a look at a few more examples. In this case, again, we're usually not going to have to rearrange in the type that we do, not that you couldn't, but we're going to group the first 2 and the last 2, and we notice in the first grouping that x is common in both, so I take x out, and I'd be with x times x plus 1. And in the second grouping, 2 is common, and if I divide 2 out of both those terms, I'd be 2 times x plus 1. And again, it's still 2 terms yet, so we're not done, but there's a common binomial factor of x plus 1, so I'm going to factor that out, and when I take that out, then I'm left with times x plus 2. In this next example, again, it may be a little harder to see, but we notice that in the first pair, there's an x common in both, and in the second pair, there's a y common in both. So I'm going to group the first 2 and factor that x out, and I have a plus b. And in the second group, if I factor the y out, I'm left with a plus b. Now, because my 2 binomials that are left are identical, we now can continue this process, factor out the common binomial factor, times, and again, once I take that out, then I'm left with x plus y. Now, this last one's just a little bit trickier. Anytime, first of all, if we're going to group the first 2 and then the last 2, if there is a minus sign between that, I must add the opposite. And so when I group this, that negative sign is inside those parentheses. And now I'm going to factor out of the first term. I notice that 2pq is common in both terms. And if I divide both terms by that, I'm left with q plus 2. Now, because this is negative 3q minus 6, and I know I need to get q plus 2 as my common binomial, I'm going to factor out a -3 like we did at one of the first examples of reviewing greatest common factor. And when I divide both by a -3, notice how both those signs are going to change. And so now my common binomial factor is exactly q plus 2. So now if I factor out the q plus 2, I'd be left with, if I take that out, 2pq minus 3. And now I have that factored into two binomial factors. I know this is getting long, guys, so again, take a moment here to pause the video, work these problems, and then I'll reveal the answers to them in here in just a moment. So go ahead and pause it. All right. Hopefully you've had an opportunity to work these problems now, and we're going to go ahead and reveal the answer. Again, notice that in this case, we have it set up already for us, and so I'm going to undistribute that common binomial factor of c plus d, and then I'm going to take that times 3 minus a, and I'm done. In this particular problem, again, these are being added. The common binomial factor is x minus 2 times 6 plus y. In this next example, it appears that because there's m's in the first two terms, that I could group them, and the last two terms have an n. So I'm going to first factor out the m, and I'm left with x plus 5. And I'm going to factor out the n, and I'm going to have x plus 5. And now I have the common factor of x plus 5 times m plus n. And then this last one again, notice that I have that minus sign between the two middle terms, so I'm going to make that plus a negative. And I'm going to group the first two and then group the last two. So I'm going to factor out an a out of that first grouping, and I'm left with b squared plus 5. Plus, now because I need this binomial to be both positives, I'm going to have to factor out a -6 to make that b squared plus 5. Now I have that common binomial factor of b squared plus 5 times a minus 6. And I've completed my problem. Again, I apologize, Titans. I know this video is a little longer than what you'd like. If you have anything that you're confused with, go back and rewatch some of those items. We'll continue with this process tomorrow in class. Be prepared to come ready to factor some simple ones and have questions ready to be answered if needed.
Made with Doodlecast Pro.